Hello, welcome everyone. My name is Olia. I lead developer experience at Rootstock Labs. Rootstock is the first and longest running Bitcoin sidechain. What makes Rootstock special is that it's fully EVM compatible. So you can write your smart contract in Solidity and also use the tool chain with integrations and tools that are EVM compatible that you might be familiar with. We've created a series to walk you through some of these tools and integrations to make sure that you are fully equipped for building on Bitcoin with Rootstock. Today, we are talking about a very important notion in Web3, which is account abstraction. And we have wonderful Nikhil with us from Etherspot, who will be telling us about the project, why account abstraction matters, and how you can get started. So without any further ado, let's start. And Nikhil, would you like to introduce yourself?
Yeah, thanks for the warm welcome, Olia. I'm Nikhil. I've been working as a developer at Etherspot for like about 5, 6 months now. And basically, I work on the backend systems trying to make abstraction great again. So, yeah.
Nice, welcome. So tell us, what is account abstraction?
Basically, account abstraction is something which basically let me get started with the introduction of how Etherspot came into the whole picture of how the Etherspot came. So basically, the team has been working since 2017. Everything started with the Pillar wallet, which was a EOA user for EOA wallet, which gained traction even before when L1 and L2s were very much popular. Since then, Pillar Wallet has been there, and we noticed the usability difficulties with EOS. And then since then, we have started the innovation of, started working on smart wallets, which is basically you don't have to bother about, your private keys or anything of that matter, where it just improves the user experience a lot. So since then, the smart wallet innovation has been rebranded under the name Ether. Yeah, since then, Etherspot has been working on account abstraction and chain abstraction for it.
Awesome, thank you. A long time ago, especially for
Yeah.
crypto. That seems like a lifetime. All right, cool.
Yeah.
Nikhil, would you like to maybe tell us more about the project? I know you've got a depth to walk through. Do you want to share your screen, perhaps?
Okay. Like I said, Etherspot has been working on the account and chain abstraction front, and there are so many wide range of products and services and SDKs to offer. So let's get started with the deck. Yeah. So this is the whole the suite of solutions which Etherspot has to offer. Basically, we have a couple of SDKs. We have Arca Paymaster, Skanda Bundler, and chain abstraction solution, which is under active development right now. We have multi-chain APIs and a transaction kit. I'll go through one by one and explain what exactly it does and how it helps to develop Web3 products with making use of the account abstraction. To start with Modular SDK is compatible with entry point v7, and it's also compatible with 7579 ERC, wherein the standardization and unification of the account happened. So the SDK is user friendly, and it's completely open source. If someone is interested to contribute, they can do as well. So this is it is totally compatible with entry point v7. And moving on to the Arca Paymaster service, which is also open source. Most of them are open source, whatever the SDKs and services which we develop here at Etherspot. The Arca Paymaster service, it's completely developed using Fastify and TypeScript, which is a paymaster service which allows user to make use of allows user to do gasless transaction. User doesn't have to worry about gas at all, making use of this service. And also it has so many other services to offer, like let's say users can deploy their own verifying paymasters. They can make use of a Etherspot paymaster contract, which is compatible with v6, verifying paymaster contracts, which is compatible with v7. And we also have multi-token paymasters wherein with one single deployment, you'll be able to specify what are the different token addresses that you are willing to accept. So yeah, that's about Arca Paymaster service. And we have Skandha Bundler, which is a 4337 bundler client, which is basically compatible with 4337 again, which helps you to make multiple user ops. You can send multiple user operations to the Skanda Bundler, and that is relayed onto the chain after bundling. I'll get to the demonstration part of the Skanda Bundler later on. And we have chain abstraction solution, which is being built using an intermediary service called SUA, which basically behaves as we make use of its the confidential compute requests and confidential storage, wherein we can lock the assets, and then where solvers can provide upfront liquidity, and then they can make use of the session keys whatever are created and stored on the confidential storage to claim their funds back and execute user intent successfully. So that's not that chain abstraction solution. It's being under active development. And also we have multi-chain APIs. Multi-chain APIs, basically we have let's say you want to have balances or transaction history for any chain for that matter. We have multi-chain APIs, and then basically, and also you can make use of the multi-chain APIs. It provides you the services for any wallet or any DeFi product would require. And also we have, if you want to make cross-chain swaps, or if you want to swap your tokens, we have APIs and services which can provide you the contract routes or the transaction routes, which can be made use on the UI to make the cross-chain swaps possible. And we have transaction kit. Transaction kit is a React library which can be made use to which under the hood uses Prime SDK and Modular SDK again, which can be made use to render user-friendly React components out of the box. You do not have to worry even about Modular SDK and Prime SDK. It uses it under the hood, and you can sign user ops and send transactions. And we have Prime SDK, which is similar. Both the Modular SDK and Prime SDK are very similar, but given that the Prime SDK is compatible with entry point v6 and Modular SDK is compatible with v7. Let's move on to the next slide. So account abstraction, basically, what is account abstraction? It's a tough question to answer. So account abstraction is something it basically allows you to build your own logic as per to how your wallet has to work. You can customize the logic as to how your wallet should work, which is not at all possible if you are using external owned accounts. So that's one of the important key features of account abstraction. One of the best examples which I can give right now is you can have multiple owners for your wallet, wherein if you want to move funds out of your smart wallet, you would have to need both of their signatures. Otherwise, you cannot move funds. So that way it enhances security, privacy, and everything. So these are the three key points of account abstraction: smart wallet, paymaster, and bundler. So one being gasless transaction. It is totally possible to make gasless transactions if we make use of a key account abstraction feature, making use of the paymasters, and then user do not have to worry about the gas fees at all. And social logins at Etherspot, here we have multiple ways to onboard users seamlessly using social logins, be it Google, Facebook, or anything for that matter. And we have one-click action TX. I'll get to that in the further slides. There is a video demonstration where you can make a cross-chain swap using the single click using HoneySwap. And then we have session keys. Session keys is something which is very important, which is also being used as a technique on chain abstraction front as well, wherein we create a key pair on the fly, and we'll be able to specify the spending limits for that particular key, and anyone can on user's behalf, anyone can use that key to make the transaction. So it's not necessary that user will have to sign for that transaction. User can just create the session key. It's one of the main use cases of session key can be scheduling the transactions for say. With EOS, this is not possible at all, because whenever you are to sign a transaction, you would have to sign it manually by yourself, because only you own the private key. But with account abstraction and smart wallet, we can make use of the session key, wherein user will just create a session key and say, this session key can be used at this time, and these are the spending limits of it. And at a later point in time, anyone can make use of these session keys and then send the transaction. So that's one of the major use cases of session keys. And we have recovery options, to make sure you can add guardians to, increase your protection on your smart wallet. And you have sponsored gas again. You can pay with any token you want. You do not necessarily have to have the native crypto of of the corresponding chain. Let's say in case of Rootstock, you do not have to have RBTC in the first place. If you have any other corresponding ERC20 token, you'll be able to still, send the transaction out. And no need of seed phrases, and you don't have to remember the, your private key. You don't have to do that at all. So everything is available at Etherspot. So yeah, let's move on to the next slide. So moving further, I'll be explaining a couple of ERCs, which are very important to understand how account abstraction front works. And later on, we will move to the demo part, wherein we make a few transactions, making use of the Skandha Bundler as well as the Prime SDK. So yeah, let's just first try to understand what ERC 4337 is, which was one of the major revolutionizing EIPs for to make account abstraction come to life. Basically, the ERC 4337 uses alternate mempool to enable account abstraction without making any changes to the consensus layer itself. The major, roadmap of Ethereum is to, remove the use of EOAs completely. Abstract it away completely from the user. But to make that, it would require a lot of consensus layer changes itself, which is very time consuming, and it could take a lot of time for very obvious reasons. So ERC 4337 is one such improvement wherein you can you can use alternate mempool and enable account abstraction. So that's one of the major highlights of ERC 4337. And you can obviously batch multiple operations. Let's say, for example, I think everyone might have experienced this. While they're interacting with a DEX, they will always have to approve a ERC20 token, only then make a swap. But then that's not very user friendly, because you will have to always wait for the approval transaction to go through first. Only then you will be able to make the second transaction. But with account abstraction and ERC 4337, it's possible to batch multiple user operations. Not only two operations, you can batch so many operations together, bundle it, and relate to the chain. So that's one of the major benefits of 4337. And gas abstraction for dApps, again, you can pay with using the paymasters. You will be able to pay for gas using different tokens. And yeah, it simply simplifies the transaction and the way we interact with chains. You can do so many things with a button click, with a single signature, which enhances the user experience, simplifies the transaction, and provided gives you not compromising with security and privacy as well. With 4337 in place, it gives you a flexible programming layer, that being your smart contract wallet itself, wherein you can add your own logic, and you can define the way how you want to make your smart contract wallet work. Yeah, and also it's not like it cannot work with the traditional wallets alongside. It is completely backward compatible as well. It can work with the traditional wallets as well. Yeah. Moving ahead, this is a diagram which depicts how ERC 4337 works. We have the user over here, which generates what he wants to do, like the user operation. It can have multiple operations within itself, and that is given to the bundler using the RPC method called ETH_send user operation, and then that user operation bundler will take care of that operation. And bundler can also take in as many user operations as it wants, as it can, from other users as well. It's not that it will only accept user operations from one user. It can, in a single bundle, it can bundle multiple user operations from different users as well, not necessarily only one user. And then this is relayed on to the entry point contract, and entry point contract will in turn make call to your smart wallet, and then tries to validate and executes the operation. If you have specified to use a paymaster, then the request is requested from the paymaster module, and then once the payment is confirmed, and then if paymaster is specified, once the confirmation of payment is received, and then the user operation is executed, and then the entry point will notify to the user back. So this is how user operation flow works in a 4.3.7 standard. So yeah, moving on to Skanda. So basically, Skanda is a TypeScript implementation of 4.3.7 bundler client, which is a developer-friendly, highly configurable, and extensible and modular. And it has capabilities. It has one of the key features is that it has advanced analytics and monitoring using Prometheus. Prometheus being open source and free again, anyone can make use of that. And yeah, it's safe and secure and fully open source. If anyone wants to contribute, they can do that as well. Yeah, and it's
Question,
one
Nikhil,
of
what
the
is Prometheus?
Prometheus is something which is used for monitoring, which is basically a tool which can be used for monitoring and analytics purposes. Wherein, let's say for example, in Skanda, we are using Prometheus to monitor how many user operations are sent and relate to the blockchain every time, and we have metrics. You can define your metrics, and we have we have so many metrics. I'll get to that when I show the code and demonstrate what are the various metrics we use to kind of instrument and analyze and instrument how efficiently the bundler is working. So that's what it is used for. And it's Skanda is one of the top rated services on GitHub. So this is the high level architecture of how Skanda works and what are the various packages it contains. Basically, we have a application layer wherein the HTTP server and HTTP port is exposed. We have WebSocket capabilities as well, and then comes the configuration layer wherein you can manage the config, and then you get to decide like the configs of it. If you what are the ports we'll be exposing on the application layer, and do we want it to run on safe mode, unsafe mode, and all of that. uh, that can be configured here in the CLI and config management on the configuration layer. And we have processing layer. This is where the meat part of the logic lies for Skanda, wherein we have support for P2P network, and then we have a executor module, executor package. Basically, P2P network allows you to connect to different bundler clients, and then relay user operations to each other, and then those two bundler clients can communicate seamlessly using discovery, gossip, and sync, which are modules of libp2p package. Uh, and then we have the executor layer, wherein the validation of user ops, bundling of user ops, and then the mempool service, obviously, wherein we store the user ops, and then that is carried out to the chain. We have storage layer. Right now we have two modules on storage layer which user can choose from. One of it is RocksDB and one of it is LocalDB. Uh, because it's open source, everyone prefers to choose LocalDB when they're testing it out locally and everything. But then the hosted version of Skanda uses RocksDB. We have monitoring and metrics. Just like before I said, we are making use of Prometheus, and we have health check alerts whenever something goes down. We will have, so that we are notified. Uh, and then we have external services which makes use of oracles and RPC nodes to get to know what are the exchange rates and gas rates and gas data, basically gas or the fee data of that particular chain. And then we have the RPC node also, which we will use to make the Skanda bundler work as a RPC node itself, not just the bundler client. Yeah. So one of the major key features of Skanda is the shared mempool, uh, for which we have received a grant from Ethereum Foundation also for the shared mempool innovation recently, which was released during the DevCon 2024. It uses libp2p to connect with different bundler peers, wherein this connection happens with two stages. One is where the discovery of the node happens using the boot ENR, and then the other bundler clients can make use of this ENR and to connect with each other. So after that, the syncing happens between the two bundler clients, wherein the user ops are exchanged between each other. Uh, so imagine this. Let's say we don't only have one bundler client, but you have multiple bundler clients which are, P2P connected. Let's say if one of the bundler goes down, or for some reason it was not able to send transactions or carry out your user operations, the other bundler can easily do it because they are P2P connected. The user operations can be relayed to the other connected bundler client peer, and then this mitigates the single point of failure and makes the execution of user operations more reliable. We already have a shared mempool with uh, Vo- Voltaire and Cilius. So yeah, this is already live, by the way. Yeah. So let's now go on to the Skanda demo and understand how we can run this locally. I have my Skanda repo cloned onto my local. Uh, so let me just go through with the folder structure of how the code is designed. Basically, we are using Lerna and then NX to manage the packages. Let's say we have around like 10 packages, API, CLI contracts, and all of these 10 packages. We have 10 packages, and all of these packages are managed using Lerna JSON. Lerna, which is a good tool to manage if you have multiple packages within your same product or same project. Uh, I'll just do nx npx nx graph. Let me just install the dependencies first. Let me do yarn. Also make sure to have node 18 version running in your local, uh, because node 18 other node version seems to have problem with with the dependency installations. So I would suggest using node 18 as a execution environment to run Skanda. Uh, we'll just wait for the dependencies to install. Once this is installed, I'll try to build this using do this. This will you know uh, build the individual packages. Mm. The output of it is under the lib folder of each individual packages. As you can see, it would build each individual packages, and then these individual packages are interconnected to each other. Like each of them are dependent on one another. If I can show you, this is the output directory of whatever we did right now, the build. Uh, that's outputted to the lib folder of each and every packages. And now if I can do npx, uh, this should open my local server of nx, wherein I can see how these packages are interconnected to each other. If I do this, if I can see CLI is dependent on all of the other packages. As you can see, it's dependent on DB, it's dependent on API, node, executor monitoring, and types. And then if I can go to contracts, it's a standalone package. It doesn't depend on any other packages as such. And then we have executor. The outgoing edges from this node says that uh, it is it is using that package. So let's say if there is a outgoing edge from executor to types, that means that the executor package is dependent on types package. And then the other way around, if you have an incoming edge, that means that the other package is dependent on this package. So yeah, this is kind of a good starting point if you want to explore Skanda's code. It would help you to understand what are the starting points and where to start from, because uh, I would suggest starting with the packages which are standalone and doesn't have any dependencies. Starting there would be a very good point. Yeah. So let's now understand what does this each individual packages do. Let's say we have API. API is basically responsible to expose your HTTP and WebSocket servers. And the CLI is something wherein you can specify what are the different flags you can send when you're trying to start a Skanda node. You can just do that by the --help. This should give me all of the different uh, flags which I can specify when I want to run Skanda. Uh, Basically, the major commands being node and standalone. If you want a standalone bundler client running, then you can use the standalone command. Otherwise, if you want the P2P interface, then you can make use of node command. And these are the flags which both of them take. If you want to specify, if you want to allow only certain number of certain origin, then you can specify it by using API calls, and then the address at which you want to expose your HTTP server, the address and the port, and you can say if you want logging or not. And this is the WebSocket server. What is the address and port if you wish to have WebSocket in your bundler client. And then these are the same goes for P2P as well, which contains the host, port, and ENR host and everything. Uh, yeah, it's pretty much self-explanatory if you can just go through and understand what are the flags over here. And the other options are unsafe mode. Basically, the important one being unsafe mode. Unsafe mode is something which comes in handy when you're doing local development, and then it would basically help. It would basically bypass the opcodes and the stake checks, which are the specifications of the ERC 7562. If you run it on safe mode, then it will go through all of the opcode checks and the stake checks for a user operation. Let's just run a standalone bundle client for now. Do this. Yeah, so they should run your Skanda bundler, and then it's listening at port 14337. Let me just copy this and then try to make some request to this server. Let's say this is my server, and by the way, this is already running on Rootstock testnet. So this is my config JSON default. You can specify whatever entry point you want to use, and you can specify your private key, which will relay the transactions to the chain, and then the RPC endpoint. This RPC endpoint, I am currently using Rootstock testnet RPC endpoint, and then I have a entry point forwarder deployed already there, which I'll make use of. Entry point forwarder is basically to uh, make estimations, wherein before sending it to the chain, we will make estimations to understand what are the gas fees this might incur. Basically, to do validations and all, we would need the entry point forwarder contract to get to know what are the gas estimations. So that's why we would need a entry point forwarder deployed instance. And then let me just go here and say, for example, I'm just making a regular ETH get transaction receipt for a transaction receipt. If I do this, so basically what it does now is it's not only because I specified a flag over here called redirect RPC, it will redirect the normal RPC calls also to the entry point RPC endpoint, whatever you specify over here. If you wish to not have this, if you wish to only have 4337 specific RPC endpoints, then you can omit this flag, and then these methods would not work then. Let me just do it should not take any params. As you can see, this is 1F, which is 31, the chain area of rootstock, and you can do various other block number. You can always query what is the current block number of the chain, of the rootstock chain, testnet that is. And then let's say I want to know what is my config. I can use this method, which should give me the chain ID and what is the relay address I'm using, and then what are the user of gas limit specifications which I'm using right now, and the entry point forwarder contract, and all of those things, and what is the bundle size. All of these things you can specify on your config JSON. Yeah, these are some of the normal calls which you can make use of after running your bundler client. Yeah. Yeah. So this is how you run your Skanda bundler on Rootstock. Now in the next demo, I'll demonstrate how I can make use of this Skanda bundler to relay user operations using the Etherspot Prime SDK. Also, I would like to show one more thing, which is how can we run P2P bundlers. I will just look at this. So this is a README file on Skanda repo where you can find if you wish to test P2P, how you can do that. You will have to have get dev if you wish to deploy all of your smart contracts locally and test them out. Otherwise, you can just skip this part and then let me just copy this and try to run this. This should run me a boot node. I think there was some issue. I'll just do a yarn clean and then try to build this again. Yeah, I think I would need some time on this. I'm not sure why this is not working now.
Yeah, that's right. You can just keep that one with the next one.
Yeah, I
It's
mean, I
the
just,
correct demos.
yeah, I mean, I think it's something minor, but I'm unable to figure it right now. Uh, Let me just walk through the README itself, wherein I can, explain how to, run P2P
That's good.
connections. Yeah. So to run the boot node, we can just make use of Skanda node, like I explained before. If you want to have a standalone server, then you can make use of standalone command. If you want to run P2P interface nodes, then make use of the node command, and then redirect RPC, executor and bundling mode as manual. This should give you out a ENR, which you can make use to run other bundler clients. Just use uh, the below commands to run different RPCs. I mean different bundler nodes which will connect P2P. So on this command you will have to specify what will be your data directory and the API port and everything. I mean these are all optional, but you will have to specify the API ports if you are running locally, because the defaults one will already be taken by the other one. So you will have to manually specify them to just change this to the default one uses 14.33.7. You just change the last one and make it 8, and then you get the idea. And then specify the ENR here which you got after running the first one. The same goes for here also, wherein you use db2 folder, not the db itself, wherein the mempools and which is basically a file storage where the user ops and everything are stored. That is the data directory. And then you change the port to a different one over here, and then give the EN or whatever you got from here. That should connect all of your connect the bundler P2P, and then both of the bundlers whatever you run here will be able to relay user ops to each other. So yeah. That one. Moving back to the presentation again. That was the demo for Skanda Bundler. We will now move to the other ERC, which is ERC 7579. Basically, this ERC is something which unifies the smart wallets and provides a standardization for smart wallets, and how what should be the implementation, and standardizes the implementation for individual smart wallets. And then the advantages of this is it increases the interoperability between different implementation of smart wallets, because if there are no standards, it will be very difficult to have a common implementation uh, across smart wallets, which would drastically reduce the interoperability between smart accounts. So this ERC aims to enforce those standards and unify the implementation of smart wallets. And then what this would do is it would enhance the module composability. I'll get to that module in the next slide. Uh, Basically, where a single user operation can invoke multiple modules, wherein you can, if your smart wallet is 7579 compatible, then you'll be able to install these multiple modules, and then this would help whenever a user op is being executed. This can help to invoke multiple modules which you have installed and authorized to your smart wallet. Uh, and then this would simplify integration, minimize fragmentation, and allow developers to get innovative without thinking about how would interoperability work when it's integrated somewhere else between dApps and all of that. Uh, so yeah, this is 7579. Moving on to the next slide. This is a small diagram which depicts how a smart account works. Basically, there are the 7579 standard gives out three popular types of modules, which are validators, hooks, executors, and fallback handlers. These are the four different types of 7579 modules, wherein validators help to which would have a specific I validator interface, which is defined in the standard, which every module you develop, validator module you develop should have those particular functionalities. And then there are hooks, which basically contains pre-check and post-check functions, which are invoked when a user operation is being executed on a smart wallet. And there are executors, which defines basically how a execution of a user operation should happen. And then there are fallback handlers, which are basically uh, to have these are modules which are used when whatever intended action was specified by the user. If it's not there, then the fallback handlers are kicked in, and then that can also be one of the modules. Uh, so Next, moving on to the Etherspot Modular SDK, this extensive module support, we, uh, wherein you can manage your modules on top of your smart wallet. Let's say, for example, if there is a new module which you have to implement, and you can have a look at the suite of modules which are available right now. I can just go and I go to modules. So these are the various modules which are widely accepted right now. Uh, there is email account recovery developed by Rhinestone, and there is a ECDSA signer, and then there is multiple owner ECDSA validator which is developed at Etherspot itself. If I can open this, this should take me to my Etherspot GitHub, and then there are a couple of others which are developed at Etherspot. I think the hook multiplexer is also one of the things which can be used to have multiple hooks. Yeah, and then the ERC session key validator also. This one is also developed by Etherspot. So these are some of the validator ERC 7579 modules, which any smart contract wallet compatible with 7579 ERC can install to their smart wallet and make use of it. So yeah. So Etherspot Modular SDK allows you to do that. You can install any 7579 compatible module into your smart wallet and then make use of it. And then this is completely compatible with 7579 and safe and secure, obviously. And it is also fully open source. Yeah, let's move on to the demo for how we can send user ops using Prime SDK, which is compatible with V6. I just open my VS Code. Before that, I think I closed my standalone bundler. Let me just rerun that. Yeah. Let me open Prime SDK over here. This is my Prime SDK which I have cloned already. And then you can always go ahead to these examples, which basically demonstrates you how you can make use of this to integrate into your wallet or dApp applications. So basically, I have the bundler URL already replaced to the local bundler which I ran just now, and then I have a public bundler API key which can be used to interact with it. I mean, this is not needed now because you are running everything locally. But if you were to use it on a hosted environment, you would need a bundler API key. I'll get to how you can create keys on Etherspot to make use of how you can make use of that to uh, make these scripts work. Uh, and then I have my Prime SDK instance, which is initiated over here. Basically, you will have to have a private key on your .env file, and then the chain ID also. Right now, everything is pointed to either a rootstock testnet right now, and then the Etherspot bundler instance as well to interact with the bundler client. So yeah, first let me just try to get what is my smart wallet address associated to the private key, whatever I have right now. You will just have to add this and these two properties to your env file, and it should work. Uh, I'll just say npm run get address. Now, what is happening under the hood is we are using the bundler client as the JSON RPC provider. If I can see this, all of those calls should be coming over here. If you can see, there is the ETH call which is happening to the Rootstock testnet, wherein I am trying to get the corresponding counterfactual address, which is a create2 address for this particular associated private key. So this is my Etherspot wallet address. So yeah, that's how you can get what is your Etherspot wallet address, and then you have transfer funds, wherein in this script you'll be able to transfer the amount whatever you specify here to this recipient. Let me do that. Transfer funds. This is my balance. This is the balance of my Etherspot smart wallet, and this is the estimate user OP. Once it's successfully estimated and it's saved in the mempool, the the bundler will return you a user operation hash, which will then be related to the chain. If I can open the logs of my locally running bundler instance, I think now we are trying to get the user operation receipt. It's already been related to chain, and then we are just waiting for its confirmation on chain. I can show this on the Rootstock Explorer as well. If I can open this, I go to internal transactions. It's not loaded over here, but it's still waiting for confirmation of the transaction. Sometimes it'll time out because we are only running it for 1 minute, but then again it should have been related to the chain. I think let me check my logs over here. Yeah. So basically, this is the bundle submitted. This is our transaction hash. Let's just open it on the Explorer to see what's happening with this. Yeah, if you can see, this is already successful. It was successful 30 odd seconds ago. And then if I can open internal transactions of this, you'll be able to see because the amount was very less, whatever I sent. Let's just try to check the balance to see, if it was actually successful. I had a balance of 9569, and then I tried to send 5 zeros followed by 1. If I can just print the balance here, if I can. Yeah, this is basically reduced by 1 decimal. So the transfer has happened to this recipient address. I can do this. Then I can see a minute ago it has received some RBTC which was incoming. So yeah.
Thanks so much, Nikhil. There was so much to cover. Very in depth. Loved it though. So much to dive into. A couple of questions I have. One is love the demos. If somebody was to follow some sort of flow to get started, where would one go? Do you have some sort of getting started tutorials, or is it on the blog? Is it in the docs? What's the best way?
Yeah, I can share you a link which contains, all of the documentation on how you can make use of Skanda to make different requests and what are the parameters you will have to pass in, like what is the request specification. I can share you the link for that. Let me do that right for, okay. Yeah, I just dropped the URL. So this should contain all of the documentation as to how different services can be used. And then the SDKs, we have the example scripts, and then that should be good. I think the documentations are quite extensive. If looked at, I think people should get a good idea to get started.
Awesome. Thank you. And if somebody has any questions or is having trouble, where's the best place to go?
I would say Discord. We'll be active on Discord always, so just feel free to drop your questions or queries, whatever you have. We'll be able to sort that out for you.
Nice one, thank you. All right, cool. Well, thank you. That was wonderful. That was so in depth. Absolutely loved it. Nikhil, it was great to have you with us today. And then to all the community, do join Etherspot on Discord. Join Rootstock if you haven't already. And happy building and see you soon.